Okay, we have a lot on our plate today. What I want to do is I'm moving into the theory of integration, and I'm throwing a lot at you right now. But first, I want to point out this is the definition of the definite integral. And by a definition, it means that this is the mathematical object that we represent using this notation. So this is a pretty complicated thing. And if you look on page 309, which I'll find for you in a second, you have that definition. So I'm just taking that definition from the book. And what we're going to do is try to understand what this is. Now, the biggest thing that this is, and this, again, this is going to take a few days, so don't try to get it all now. So just kind of looking ahead, next week we'll show that this summation is equal to g of b minus g of a, where g prime of x is f of x. In other words, g of x is the antiderivative of f. I know it's a complicated way to say it. It's pretty standard. In other words, what we represent by this symbol is equal to this. That's the definition. And we'll prove that this is actually equal to this thing. So that's why when we integrate, we start here and we anti-differentiate. Again, I'll take this in small pieces. Now, it also turns out that this summation is equal to what I call the area above minus the area below, and I'll explain this, where if we have a graph f of x, we have an a and a b, that a plus is the area below y equal f of x, but above the x-axis. That's what the above stands for. So it's this area in here, and that would mean that a minus is the area below, and it's the area above the graph below the x-axis. So basically what we're saying is that when we write this down, this is what we really mean. We'll prove that this is actually equal to this simple expression, and we'll prove that this simple expression actually equals area above minus area below. So, but I'm going to start slowly, and I'm going to do it piece by piece. And so we'll make more sense of this. This is just sort of to give you a sense of where we're going. There's a lot of notation. So we're going to answer a lot of questions. What's this thing right here? What's CK? What's delta XK? What's this N? And we're also going to see things that look like this: X0, X1, Xn. And again, there's a lot of different things to answer. So we're going to go through this piece by piece. So in order to explain where this idea right here comes from, I'm going to do an exercise, and the question is going to be, find the area bounded by y equal f of x, where f of x is greater than 0, x equal a, x equal b, and the x-axis. So in other words, I want to find this area. Now I'm going to set this area up in such a way when we answer that question, what we're going to get is we're going to get a sum, and I'll explain what that sum means, and then that sum is going to represent this. Again, we'll take this piecemeal. I just threw an awful lot at you at one time. So that's the introduction to the problem, and then with the next video I'm going to start at the real problem.